Hello friends, today in this session we will discuss projection of a solid when its one face, not the base, one face is inclined to horizontal plane and vertical plane both. And I will take an example of a square prism where the top face is A, B, C, D and bottom face is E, F, G, H. This is a square prism. Top face is A, B, C, D and bottom face is E, F, G and H. And let us assume that this face A, B, E, F is inclined to horizontal plane, vertical plane both at angle alpha and beta respectively. So that means this face lies in the oblique plane, which makes angle alpha beta with reference plane. So let us first draw the vertical trace and horizontal trace of oblique plane, and you can do that either by cone method or by perpendicular line method, and this we have discussed earlier in our sessions on oblique planes. You draw a circle of any radius on the ground line, and this is the diameter of this circle. Draw a tangent to this at angle alpha here, a tangent to this circle at angle beta, and this is a point A, this is B, this is C. From B, and let us say this is D and this is E. From B, you draw a semicircle in the bottom part of the, and from B again you draw a semicircle BE radius in the upper part, and that gives you the vertical trace and horizontal trace. This you can see my earlier video how to draw BTH of an oblique plane when its angles are equal. This is the vertical trace and horizontal trace BTH. Now once you know the vertical trace and horizontal trace, then as usual we convert this oblique plane into either inclined plane or into A. Because I told you earlier also that any object cannot be directly placed on oblique plane. And let us convert this into an idea. Conversion of oblique plane into auxiliary planes we have discussed in earlier session. So you take a AVP here, which is perpendicular to horizontal trace, and project this vertical trace on this AVP. Take a point here, and from this point you draw a projector. Take this distance equal to this distance, you get new vertical trace T1, T1, H1. Now you can see here the horizontal trace is perpendicular to ground line. This is a ground line now, and vertical trace is inclined, and therefore this T1, T1, H1 is inclined plane now. But with respect to this AB, okay? So this is the ground line X1, Y1. Now let us place this solid in the horizontal plane. This horizontal plane, the vertical plane now, but not the reference vertical plane, but auxiliary vertical plane. Let us place this solid in horizontal plane, keeping this base A, B, F, E in the horizontal plane. So keep it here, and because there is no other condition, you can keep this solid in simple position when, now this is A, B, C and F and E. This is the base which you have kept in the horizontal plane, and above this base you have the top surface now. Top surface. Above A you have B, and above B you have C, and similarly above F you have point G and H. That is how you place it in the horizontal plane. In this position, its elevation of the base will be a line, and when you look from the front, you get this height here. Now, when you are placing in the horizontal plane, this face is in the HP and this face is parallel to HP at a height of this. So this height will be reflected in the vertical plane. So that is the height. And this height is same as the side of the base of the prism. So now you can name it. A will be here and B will be here. Similarly, this E will be on the ground and H will be above the ground. And C is again above. Okay, so C is here and B is here. Because A and B both are on the horizontal plane. And here E and F will be here and G. So this is the elevation. First elevation on the auxiliary vertical plane. Now you place this solid on the AB. So you rotate this face A, B, E, F about T and bring it on this vertical trace, as we do in case of inclined plane. When the base or face of the solid is inclined to horizontal plane. So first you place it on horizontal plane and then bring it on the inclined plane. So this is the now base, and this top face will be again a rectangle of the same size. So basically this A dash B dash comes here. Okay. A dash B dash comes here. E dash F dash comes here. And this is H and G. And this is C and D, or B and C. Now you get the new plan. You get the new plan. From each point in the elevation, you move perpendicular to ground line, and from the plan, you move parallel to ground line, you get new plan. So let us do that. From A, if you draw a line perpendicular to ground line, you get A point here and B point here. So this is, let us say, B1, this is A1. Similarly for C and D, if you move perpendicular to ground line, you get point C and D here. This is C1 and this is D1. For E and F, you get point here, and for H and G, you get point C. This is G, this is F1, G1, and E1 and H1. Now you get 8 points. All the 4 corners, all the 8 corners, 4 of the top face. And now again the first step is to join the boundary of projection, and boundary of projection is the outermost point, that is E1, F1, H1, A1, B1, C1, B1 and this component. That is the boundary. Now after tilting this, initially you kept it like this and then you tilt it like this so that it makes angle alpha with the horizontal plane. And now for the plan you are looking from the top. For the plan you are looking from the top. So this edge will not be visible because we have rotated this solid about this edge. And what is this edge? This edge is AB. This edge is AB. So A1, B1 will not be visible when you see from the top after rotation. This is visible now. It is also visible and it is also visible. So A1, B1 will be a dotted line. Right? And H and G, that is the top. This will be defined. Now this is the plan of the solid after putting it on inclined plane. Now from this position you get the elevation. So from each point in the plan you move perpendicular to ground line. Each point B, this is B, this is A, and this is H, E, F, and G. So you have now all the 8 points in the elevation. Now see the height. For C and D, this is the height. I told you in my earlier sessions that heights are, or distance is always measured from ground line. From old ground line to new ground line. Now here the old ground line is x1, y1 and new is xy. New ground line xy. So from old ground line, for C and D, this is the distance. Take the distance here for C and D, right? This is C and this is D at the same height. So C1 or C dash and D dash. Let me write D dash. For A and B, this is small distance, it's small height. For A and B, B is here and A is here. The same height, A dash. For E and F, this is the height. The ground line here is the height. Is the height of the point. So for E, you take, let us say here, E1, E dash, and for F, you take here, F dash. And for H and G, they are the highest point after rotation. Okay, H and G, this is the height. So for H, this point is here, H dash, and for G also you have a point here. That is your G dash. Let me remove the extra lines so that there is no confusion. Let me remove all these lines so that you can understand how this projection is drawn. Although these points will remain on your drawing sheet. These lines will remain on your drawing sheet. Now you have A, B, C, D, this point, and then E, F, G, and H. These are A points. Now again we first draw the boundary of the projection. And boundary, I told you, it is the outermost point of the projection. So let us draw it. Let us start from A dash, B dash, C dash, G dash, H dash, E dash, and A dash. This is the boundary. This is the boundary projection. And you see here that 2 points, F dash and D dash, they are inside the boundary. Inside the boundary. Now what we have done basically, initially you kept it like this, then you make a tilt to the face, and then you make another tilt to this face. So this corner will be the top at the top. Okay, so this will be visible, but this corner will not be visible. It is not below. So which corner is not visible? When you are looking from the front side, this corner is not visible, F. So all lines meeting at this F will be dotted lines. And what are those lines? You see here F, EF, FG and FB. These are 3 lines meeting at point F. So FB is a dotted line. FG is a dotted line, and EF is also a dotted line. Now let us see if there is any line which crosses this dotted line. and when the rule of projection, that should be continuous line or firm line. D is the highest point, and therefore all lines meeting at this point must be visible lines, firm lines, and therefore these lines will be the firm lines. At point D, you see 3 lines, DH, DA and DC. So DA, DC and DH. That is the firm line. This is the final projection of the square prism when it's one face. Face is A, B, E, F. This face, A, B, F, E, is inclined toward the reference planes. You can take any solid where the base or a face is inclined to both HP and B. So friends, thank you very much for watching this video. You can write your questions in the comment box.